Hello, I'm Naila Salah, and this is part 6 of the Java series where I explain Java programming step by step so you can navigate through these. This video will be all about math.functions and more on types of operators. Math.functions are built-in functions which do specific operations that require a lot more work had they not been there. They would require many operators and in some cases, if statements. In short, they limit the amount of work you have to do. Let me first initialize the variable xyz. I'll give it a value of -6.5. As you can tell here, the data type is double. This is because the value I've given xyz is a decimal. The math.functions you'll need the most and will be the most useful are: number 1, math.absolute, spelled as math.abs. Upon entering a number, it will return its absolute value. So if we enter a number that is 0 or positive, what will be returned is the number itself. But if we enter a negative number, like xyz, it will return the positive value of the number. Let's look at an example. Inside the print function, we're going to write the math.absolute function and inside it, the variable xyz. Let's print the output. As you can tell here, the value of xyz was -6.5. In the terminal, it is 6.5. Number 2, math.minimum, spelt as math.min. When entering two numbers inside this function, it returns the value of the smaller number. Here's an example. Inside the print function, let's write the math.minimum function and inside it, the variable xyz and the value of the number 1. Let's output the result. As you can tell here, the smaller number of the two was -6.5. Number 3 is math.maximum, spelt as math.max. This function does the opposite of math.minimum. It returns the value of the larger number. Here's an example. Inside the print function, I have put the math.max function and the values of xyz and -5 inside it. Let's run the program. The larger number of the two is -5. The math.max took both as double values, so we can tell in the terminal that it is -5.0 and not -5 on its own. Number 4 is Math.pow, spelled as Math.pow. In this function, you enter the base, a number, and the index, the exponent. So it basically returns the result of the base to the power of the index. An example is, inside the print function, I'm going to write math.pow and I'm going to assign the base to be 2 and the index to be 5. This means I'm asking the computer to output 2 to the power of 5. In the terminal, we can see that the answer is 32. It is displayed as a double value because the math.pow function allows double values, so it sets all of them to be doubles. Number 5 is math.sqrt. This is spelled as Math.sqrt. This function returns the square root of a number. Make sure if you have this assigned to a variable that its data type be a double. Number 6 is the math.cbrt, spelled as Math.cbrt. Both work the exact same way, but this one gives you the square root and this one gives you the cubic root. Let's take an example on the cube root. Inside the print function, I'm going to write math.cbrt and then -27 as the value I want the cubic root of. The answer is -3.0. As you can tell, the cube root also outputs the double, so it works just like the power. Number 7 is Math.round. This function rounds the number you've entered. If you want this assigned to a variable, then its data type is going to be integer. To round xyz, inside the print function, I'm going to write math.round and then xyz in between the brackets. This is going to round the number to the nearest integer. As you can tell here, it's -6, which is the bigger number. The 8th one is Math.ceil. spelled as Math.ceil. This function is similar to Math.round, except it rounds up the number every single time. So if there's a decimal, it's going to look for the number that is bigger than that, and it's going to round it up. Math.floor is the exact same function, except it does the opposite. It rounds down the number to the number smaller or less than the one we have inputted. Here's an example that's going to combine Math.ceil and Math.floor. Inside the print function, I'm going to write Math.floor, xyz, so it rounds xyz down, and then plus for concatenation, and then Math.ceil, xyz, for rounding up. A little piece of string so that it just separates them, it doesn't add them up mathematically. Let's run the code. In the terminal, you can see -7 and -6. This has rounded it down, this has rounded it up. In the previous video, we've discussed 3 kinds of operators which are important for writing Java code. In this video, we'll be talking about 2 more, assignment operators and unary operators. Let's start with assignment operators. These operators simplify assignment equations. Instead of writing a whole line of code while repeating the same variable a million times, we can use these operators. Assignment operators are the following: the plus equals, minus equals, times equals, by equals, and mod equals. Assignment operators are the grown older siblings of arithmetic operators. They function in a really similar way. An arithmetic operator will combine 2 variables or values together and then return the result. Assignment operators, though, combine another variable or value to the variable and then assign them to that same variable. All they do is, instead of saying xyz equals xyz plus 1, for example, they replace equals xyz plus and write plus equals, as in to assign this value to the variable. If you don't know what the modulus sign means, it basically divides 2 numbers together and then returns the remainder of that division, and not the result itself. Let's take an example on the modulus equals. What I have done is write xyz mod equals 2. This operation is basically going to be the value of xyz, which is -6.5. It's going to be divided by 2, and whatever the remainder is going to be assigned as the value of xyz. So xyz is no longer going to be -6.5, but the remainder of this operation. Let's output xyz. After pressing run, we can tell that the remainder is -0.5. Why is that? Because when we did the xyz mod equals 2, the remainder was -0.5. So now the value assigned to xyz is -0.5. All the assignment operators work in the same way. They combine the variable with an operand and then replace its value to be the solution. Unary operators are going to be a little unfamiliar for people who have never learned programming before. They perform a new kind of operation. Unary variables could be hard to grasp at first, but with practice, you'll find that they're one of the most practical operators to use. They're used a lot in all the types of loops. They do serve a function elsewhere though. There are 4 unary operators: the pre-increment, the post-increment, the pre-decrement, and the post-decrement. Do you remember what the prefixes pre and post meant from when we were in primary? That's exactly what they mean in Java. Pre means before, and post means after. Now to the serious stuff. What are increments and what are decrements? An increment is when a number is increased by 1. See what I did there? Increment comes from the word increase. Now that we know an increment is when a number is increased by 1, we can conclude that a decrement is the opposite. It is when a number is decreased by 1. Decrement comes from the word decrease. But you'll now ask me, Leanne, what do the pre and post prefixes do if an increment increases and a decrement decreases? They're going to increase or decrease either way. I'll tell you. It all has to do with your computer memory. When we say a pre-increment has been added to a variable, it means that if an operation were to happen in that moment, the value of the variable would increase by 1. When a post-increment is added to a variable, and this might be confusing, if an operation were to happen in that moment, it would take the original value of the variable and then store its value in the computer memory as increased by 1. So if we were to add an extra operation, it would take the incremented value. Here's an example for clarification. Inside the print function system.out.println, let's write xyz++, and then write another print function and let it write xyz on its own, without any increment or decrement. After running the code, let's see the output. In the terminal, you can see that xyz++ is negative 6.5, as it took the original value of xyz and then added 1, and then stored it in the memory there, and then when we wanted to take the value of xyz, it was added by 1. Pre and post decrements apply the same concept. Let's change this plus to minus minus. As you can tell here, the first value was negative 6.5 and the second value was negative 7.5. These are post-decrements and post-increments. Let's look at pre-increments and pre-decrements. Let's erase all of this and write minus minus at the beginning. After running the code, you can tell that it has immediately taken this value. Same thing goes for if we added a plus instead. This marks the end of our tutorial, so if you have benefited, leave a like, subscribe, and don't forget to share this video with those who might also benefit from it. If you have a question, feel free to comment it down below and I'll be more than glad to help. Thank you for watching.